Question 1, Part D. Find the value of theta in the diagram. Give your answer to the nearest degree. By inspection, we're dealing with side angle pairs, so the sine rule will be applied. I'm going to write the sine rule with sine theta in the numerator. That'll help make finding the value of theta a little easier. So by the sine rule, sine theta over 5 is equal to sine 33 degrees over 9. The next step is to make sine theta the subject. It's currently being divided by 5. So to cancel out this division by 5, we need to multiply this fraction by 5, but what you do to one side of the equation, we need to do to the other side as well. So multiplying both fractions by 5, we get sine theta is equal to 5 times sine 33 degrees divided by 9. Notice that I've written it with the division symbol rather than writing it as a fraction. Sometimes it's easier to express an equation without using fractions, rather using the division symbol can make things a little easier to read or to work with. The next step is to make theta itself, which is the angle, the subject. So I'm going to do that by taking the inverse sine of both sides of the equation. That's the opposite operation of sine. So theta is equal to inverse sine of 5 times sine 33 degrees divided by 9. And evaluating this expression here, we get around 17.61 degrees, correct to 2 decimal places, which is around 18 degrees, correct to the nearest whole number. The final step is to check the ambiguous case. Because we're dealing with the sine rule for unknown angles, there may be two solutions, an acute angle solution and an obtuse angle solution. And the question itself does not state whether theta is acute or obtuse. So what we need to do is to find the obtuse angle and then test its validity by using the angle sum of a triangle test. So to find the obtuse angle, we subtract the acute angle that we found here from 180 degrees. So 180 degrees minus 17.61 degrees is equal to 162.39 degrees. Now if we go back to our triangle and substitute 162.39 degrees here, if we add that to 33 degrees, we get around 195 degrees. And that's clearly over 180 degrees, which is over the angle sum of the triangle. Hence, this obtuse angle is invalid and not a possible solution. Therefore, theta equals 18 degrees, correct to the nearest degree.